The topic of discussion is in Doubly linked list. We'll study how to insert a node at the end. Insert end means how to insert a node at the end. Fine. So that is, you have already, what we have already did, that we have seen how to create Doubly linked list, and in that we have seen menu program. Fine. Then we have seen how to print element of doubly linked list. Then we have seen insert, and insert we have seen two part till now, that is insert a node at beginning and insert a node at middle, that is at any position other than beginning and end. Now we will see insert a node at end. Let's start. So as I've already told you that insert do have its own menu, that is if you press 1 you can insert at beginning, if you press 2 you can insert at middle, if you press 3 you can insert at end. What do you want? Since I want to insert at end, I'll press 3. So ch will have 3, switch will have 3, I'll jump to case 3, and in case 3 I'm calling what? Insert end function. And you can see a linked list. Currently we have a linked list that having 5 nodes, where head is representing a node number 4 and tail is representing node number 8. Now what your job is, you have to insert a node at end. So what will actually take place? This tail will have this address, this will have this address. Now tail will become this because this is going to be the last node, and this will have null. Finally, so this is what it will take place. It's very easy coding. Let's start with the coding part. So this is insert end function. First of all, what I did, I have created a pointer of type node1. What is node1? I have already told you that when you have created doubly linked list, you have created a structure by having name node. There are three parts. One is data, two addresses. One is address of next node, one is address of previous node, having data type struct node, and we have created a variable node1. This node1 variable is the variable of a structure. Then we have type defined this structure. By using type def, what we are actually doing is that this node1 is representing the entire structure. What would happen if we do not use type def? If you will not use type def, then wherever you are using node1, node1, you have to write struct node. You have to write this complete struct node. So in order to simplify the code, we have used type def. So you must be thinking, what is the use of node1? Even struct node is not so big. You can use even a in place of node1. So this is going to be very easy now. My job is to tell you how this coding is working. So we have created a pointer temp of type node1. Now again, what I am doing, what I have to do, I have to insert a node at end of doubly linked list. Since I have to insert a node, I have to create a node. I have to insert, this means I have to create a node. So again I'll use malloc. What malloc will do, malloc will allow me to create a node, structure of a node of size node1. And what is node1? Having three parts. Fine. So suppose we have a linked list, and now my job is to what? My job is to create a node. So what I'll do, I'll create a node. So I'm creating a node at last. This is, suppose this is last. So this node is this, having name temp. Suppose address of this node is 600. Fine. Okay. So again I'll ask user to enter the data, because I've created a node. I'll ask user to enter the data. Suppose user has entered 9. So temp data will have 9. I've already explained you many times. Temp next. Temp next. Temp, what is temp? This next. There is no node after that, because if temp is going to be the last node, then there will be no node. So temp no next will have none. This is what perfectly fine. Tail next. What is tail next? Right now it's having null, but since what is coming ahead of tail, this temp, so tail next will have temp. What is temp? 600. So 600 will come here. So this node will start pointing this node. Temp previous is this, will have tail. What is tail now? 500. So this will have 500. So this will point this node. Fine. Okay. And after that, what I'll do, tail is equal to temp. I'll update tail. What is there in temp? 600. So tail will have 600. So tail will move from this place to this place. Finally, what will happen? So this 9, the node having value 9 will become the last node, and the last of that will have null. Finally, this is very simple coding. So if you do all such connectivity, you will get this structure. You will get this structure where head is representing the same 4, but tail is now tail. This is the middle part. I'm sorry. This is the middle part. Tail will have what? Address of temp, which is 600. This is yes. Temp will have address of tail, which is 500, which I have already explained you above. Fine. Temp next will have null, which I have already explained you, and finally tail will move here. So finally what will happen? The last step will be head will become same, and tail will become this, the node number 9. The node having value 9 will become tail. So this was the middle part. This was the middle part of my coding. Fine.